Okay, pre-calc. So I received some requests to do a few problems on the homework. So I'm going to start off by doing number 11 on homework 1. Okay, so this one, you did have to get pretty clever. What we were trying to do was we were given that secant of x minus pi over 2 is equal to negative 1.06, and we were trying to find cosecant. So remember, you should have your trig identity reference sheet available. Okay, and in this case, this is one of those guys where we're going to use our cofunction identities and our even odd identities. So essentially, we know that cosecant, which is what we're trying to find, right? If we look at these identities, right, cosecant is equivalent to secant of pi over 2 minus theta. So right now we have the secant of x minus pi over 2. So we don't have what we need yet, but the first thing you have to do is be a little clever here. And to get this secant of x minus pi over 2 to look like what we want it to look like, which is that pi over 2 and the theta to be switched, okay, we can pull a negative out from that entire expression. So that's going to make this negative x and this plus pi over 2. Okay? And if I just rearrange that negative x and the pi over 2, so I'm going to do something like this, pi over 2 minus x instead of negative x plus pi over 2. You'll notice now I have what we'd have on our trig reference sheet. Okay? But now I have to deal with that little negative that I pulled out. But remember, we have an even odd identity that tells us that if we have the secant of negative theta, right, it's actually just equal to secant. So we can actually just pretty much ignore that negative, right, because those guys are equivalent. Right, so we know that all these guys are equal to negative 1.06, right? And at this point, right, we have the secant of pi over 2 minus x, right? And what we want to do is somehow get that to be cosecant, and using our cofunction identity, we know that secant of pi over 2 minus x is actually equal to cosecant. So it looks like cosecant is just going to be equal to negative 1.06. So just to run through the steps again, first I pulled a negative out in order to get this guy to look more like what I have in my cofunction identities. And then I used my even odd identity, and that got rid of this negative here. And now that I have just secant of pi over 2 minus x, I know that's equivalent to cosecant. And so I was able to just go ahead and say that cosecant is equal to negative 1.06. Okay, so the other two questions were numbers 9 and 11 on homework 2. Okay, so go ahead and flip to that if you are following along. And remember, in this situation, we are trying to simplify down trig expressions, and that means that we want to get it to a single number or a single trig function. Right? So the first thing we're going to do is, right here we have a bunch of stuff going on. I'm going to start off by just changing everything using my reciprocal and my quotient identities. So I'm going to have something like this. I'm going to keep any sine or cosine. I'm going to change these guys to an x, just because sine and cosine are always going to be the easiest to work with. So I get something like that, over sine squared over cosine squared, and then this is going to be 1 over cosine squared. Okay, so now we got to do a few little things here in order to figure out how we can simplify this guy down. So what I'm going to do is I have some division of fractions, and that's always nasty. So I'm actually going to do a keep, change, flip for each of these guys to make it prettier for me. Okay, so for this first guy right here, if I keep, change, flip that, I'm going to keep sine squared. I'm going to change the division to multiplication. I'm going to flip this. So that's actually going to be sine squared of x and then times cosine squared over sine squared. And this guy I'm going to do the same thing. So I'm going to keep the sine squared of x over cosine squared of x, and I'm going to multiply it by the flipped version of this guy. And you'll notice on both sides we have some stuff that cancels. So now I'm just going to have cosine of squared of x plus sine squared of x. And then using your Pythagorean identity, we should know that that is just equal to 1, and we've achieved our goal. All right, and then for number 11, right, with this guy, I had 1 plus sine of y over cosine plus cosine over 1 plus sine of y. So it doesn't look like we can really rewrite these guys without incorporating a lot of fractions, extra fractions, and also some reciprocal functions. So I would actually shoot for a common denominator to start off. So our denominators are cosine and 1 plus sine. So I'm going to go ahead and multiply this side by cosine over cosine, and this side by 1 plus sine of y over 1 plus sine of y. Right? And what that'll do, this new numerator is just going to be, I'm just going to write it as 1 plus sine of y squared for now. Right? And then down below I'm going to have 1 plus sine times cosine. And then this other side is going to be cosine squared over 1 plus sine times cosine. So all I did there was get a common denominator. And remember, what a common denominator gives us the ability to do is to actually go ahead and add these guys. All right, so I'm going to have 1 plus sine of y squared plus cosine squared over 1 plus sine of y times cosine of y. All right? And it's tempting to think, oh, I can cancel this out, but no, that plus stops us from being able to do that. So right now we don't really have much we can do. So what I'm going to do to see if we can simplify further is I'm going to actually multiply that 1 plus sine of y out. So remember, that's just 1 plus sine times 1 plus sine, and you FOIL it. 1 plus sine of y plus sine of y, and then plus sine squared of y. So it's equivalent to something like this. Okay. So I'm going to rewrite this whole expression using that. And then we had sine squared, right? And a few things are going to go down here. What I notice right off the bat is up top, I now have sine squared plus cosine squared. So those two guys are going to combine to give me just 1, right? Because that's the Pythagorean identity. Sine squared plus cosine squared equals 1. So those guys combine to give me 1. So now I got 1 and another 1, so that's, I have 2 plus 2 sine of y over 1 plus sine of y times the cosine of y. And then to finish off, if I just factor out a 2 from the top, I end up getting 1 plus sine of y, which is great because now I can cancel the 1 plus sines. So I have 2 over the cosine of y. And you can essentially think of this as 2 times 1 over cosine. And 1 over cosine, isn't that just secant? So it's going to be 2 secant of x that we simplified down to. Oh, sorry, y. I hope that helps. Hey, good luck on the quiz. See you guys Monday.